Okay guys, welcome back to the part 2 of the SCH overwrite exploit. So in the previous video I was mentioning or talking about how we need to do a short jump over to where we have our Ds. So the next instruction we need to generate has to be an instruction we need to look for has to be an instruction that goes into the pointer to the next SCH record. So that could actually point to where we have our Ds, and then we could place our shellcode somewhere where we have our Ds. So what needs to happen now is we need to summon Nassim. Okay, so we can summon Nassim shell and then ask Nassim to look for the address for a jump short instruction. Okay, so we're jumping 8 bytes short. So you can see from here, jump short 8 bytes is actually EB06. EB06. So EB06 is the address we need to place into our pointer. So in the pointer is that's the address we need to place in there. So I'm just going to go back in here now and replace our B's with the address. EB06. However, we need, because it has to be 4 bytes long, EB06 is just 2 bytes, so we can add a couple of knobs to make it complete for 4 bytes. Great. So now we are at the point where we can then generate our shellcode exploits and place our shellcode into this Python script in order to trigger the buffer overflow exploit. So in the previous video we talked about the problem of bad characters, that whenever you want to generate a shellcode, you need to make sure you get rid of any bad characters. So if you want to really understand how to do it, I would encourage you to watch the save return address exploit using the SL mail. So I've already solve the problem of the bad characters in this scenario and identified 4 characters that shouldn't be in our shellcode exploit. So what I'm going to do quickly now is I'm going to use MSM Venom to generate the shellcode which will be used or included into our exploit. So MSM Venom, the payload we're using is a Windows reverse shell. Okay, and the hell host of this machine, which I checked earlier on. So the listening host. And the port where we'll be having the netcard connection, port 443. The exit function has to be set as well, because this does not allow the application crash once we actually send our exploit. And using the Shikata Gana encoder, and the bad characters which are identified, number 1 is 00, which is a standard, 0A, 0D, and 1A. Okay, so I'm just going to look, everything looks okay. Just to make sure everything is fine, I'm going to just check the IP address once again. And I can see now the IP address is actually 129. So I think my instincts there actually worked, because I wouldn't want to generate a shellcode that wouldn't actually trigger the exploit. So 129. So everything looks fine and we could generate the shellcode. So it's complaining no platform chosen. Right, so I think I spotted the problem there. So the platform is actually an x86, so it's a 32-bit machine, which is our Windows machine. So I think that should solve that. Excellent. So we do have our shellcode. I'm just going to copy the shellcode straight away into the exploit. So we could create a local variable here, just call it shellcode. Then we could paste our shellcode inside of here. What I'm going to do again, I'm going to put in another local variable here, and I'm going to place our knobs, because remember we talked about the use of knob sleds, just to make sure the exploit doesn't step on its toes. So I'm going to place in about 20 knobs, and I'm going to add our shellcode as part of the local an argument for the local variable. So I'm going to go ahead here and just include evil as part of the buffer, and then in the D's I'll change the D's to B's, and then as padding have 1384 minus the length of evil. Okay, so our exploit looks ready. We've got 20 knobs plus the shellcode. We've got the address, a jump shot address by 8 bytes forward for the next structure exception handler pointer. We've got our pop-up return instruction there. We got our exploits, our shellcode, and also our padding included. So everything looks okay. I'm just going to then save this file. I'm going to call this playlist 4. Copy this to the Windows 7 machine. Okay, so this time around I am not going to be attaching it to Immunity Debugger. I'm just going to select the file and then open up a Net Catalyst now, port 443, where we're going to have our reverse shell from the Windows 7 machine. So listen up, port 443. Hopefully, fingers crossed, everything works fine. Click on this, and if we go on here, there we go. Excellent. We do have a reverse shell, and the exploit has worked. We can have IP config, and we can see we do have access to this machine. We have access to the directory of this machine, and we do whatever we want on this machine. So that in a nutshell explains the structured exception handler overwrite exploit. Okay, so thank you very much.